Okay, so this is a continuation of our discussion in chapter 3, the derivatives. So this is part 3 of the series for chapter 3. So in this lecture, we will be discussing about the algebra of derivatives. So how do we operate derivatives in different operations? So the first one is the sum or difference. The derivative of the sum or also difference of two functions. So let f of x be equal to two functions, the sum or the difference of two functions, g's of x plus or minus h of x. Then we want to determine the derivative of f of x, or the derivative of the sum or the difference. So how do we do that? So derivative of f of x with respect to x, remember our definition, this is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. But this time, f of x is equal to g of x plus or minus h of x. So we need first to determine what is f of x plus delta x from this function. So what will be f of x from here? F of x plus delta x. So it's just equal to g of x plus delta x plus or minus hx plus delta x. Then we substitute it here. So this will be equal to, in terms of g and h, so this is g's of x plus delta x plus or minus h of x plus delta x. Then we subtract f of x, which is this one. So I just put a quantity here, g's of x plus or minus h of x. So this part will be our f of x, and this is f of x plus delta x. And we divide it with delta x. And simplifying here, so we have we can put g and g here. So this will be g of x plus delta x. Then I'll take the g at the right side, so minus g of x. Then plus or minus h of x plus delta x. Then I'll have here, this is negative times plus minus, so it will become minus plus h of x over delta x. Then I group this into two parts. So this will be the limit as delta x approaches 0. So I divide it into two parts, g's of x plus delta x minus g's of x all over delta x. Then I'll take plus or minus here. Then we have h of x plus delta x. Then because this is minus plus, not plus minus, so I need to multiply it with a negative. So this will be negative h of x, so that if I multiply it with plus minus, it will become minus plus over delta x. Then property of limit, we can distribute the limit. So this will be the limit as delta x approaches 0 of g's of x plus delta x minus g's of x all over delta x, then plus minus the limit as delta x approaches 0 of h x plus delta x minus h of x all over delta x. Then if you remember the definition again of a derivative here, f of x plus delta x minus f of x over delta x. So if you look at this part, this one is a derivative, and also this one is a derivative of g and derivative of h. So we can now conclude that the derivative with respect to x of the sum or difference of two functions, g's of x plus or minus h of x, this is just equal to the derivative of g's of x with respect to x and plus or minus the derivative of h of x with respect to x. So this means that we can also distribute the derivative. Derivative is distributive. So if you have two functions, the sum of two functions or difference, you can just distribute the derivative directly. So that's the first property. Then we have another one. So this is the first one is sum or difference. The second one is the derivative of the product. So this time we take the product of two functions. And we call this one, we usually call this one the product rule in differential calculus. So how do we take the derivative of the product of two functions? So again, let f of x be equal to the product of the two functions g's of x times h of x. And we want to determine the derivative of this one. So derivative of f of x with respect to x, this will be equal to, again, the definition as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So we need to find f of x delta x. So what is f of x delta x? So we base it from the f of x. So we just put we change all the values of x into x plus delta x. This will be equal to g's of x plus delta x, and you multiply it with x plus delta x. Then we again substitute this one to the equation here. So this will be the limit of delta x as delta x approaches 0 of this one. So g x plus delta x times h times x plus delta x, then minus f of x. So this is g of x times h of x all over delta x. Then to simplify this one, we need some tricks. We need to add something. We need to add 0 here. So this g's of x plus delta x times h of x plus delta x. So we need to add 0. We need to we use g's of x times h of x plus delta x. So I added something so to neutralize the equation to make it still the same. I need still to subtract it, g's of x times h of x plus delta x. So that I just added 0, so nothing happens. Then subtract the last part, g's of x times h of x all over delta x. So why do we need to do this one? We need to do this one to separate them, to simplify them further. And in calculus, this trick will be very, very useful, especially in integral calculus later on, adding 0, multiplying by 1, and so on. So here, I can now get the g's of x plus delta x. I can factor out h of x plus delta x from this part. So these two, there's a common h of x plus delta x. So I can factor that out. So what will be the remaining terms? So if here will be g's of x plus delta x, g's of x plus delta x, then here will be minus g's of x. Then I'll factor out x plus delta x. Then to the other two terms, we can also factor out the common term here, the remaining two, this one and this one. The common factor is g's of x, so we can also factor out g's of x from that. So plus factor out g's of x. So the remaining term here will be h of x plus delta x. Then here the remaining term will be minus h of x, because I factored out h of g's of x. It's g's of x all over delta x. Then next is to separate them into several parts. So the limit of delta x, we can distribute again the limit, even if it's a product, 0. So here we have the first part, g's of x plus delta x minus g's of x all over delta x. Then you multiply this one with h of x plus delta x. Then plus h of x plus delta x minus h of x all over delta x. Then you multiply again this one with g's of x. Then we can distribute now the limit. So we have here the limit of g's of x plus delta x minus g's of x all over delta x. As delta x approaches 0, then you multiply it with the limit of h of x plus delta x as delta x approaches 0. Then to the right side, the limit of h of x plus delta x minus h of x all over delta x as delta x approaches 0, then times the limit of g's of x as delta x approaches 0. Then we can now take the limits. So at the first part here, the limit of g's of x is delta x minus g's of x over delta x. This is just the derivative. This is the definition of derivative. So this will be equal to the derivative, or it's g prime of x. Or we can use the notation. I can just write it derivative instead of prime. Derivative of g's of x with respect to x. Then times multiplication, the limit of h of x plus delta x. So what happens if we take delta x approaching 0? Delta x will be 0, so this will be 0. So what will be the remaining term? It will be, it's just h of x. Then here, again, this is derivative of h of x with respect to x. Then the limit of g's of x as delta x approaches 0. There is no delta x in the term. Then It's just the g's of x. So now we derive the product rule. So this is the derivative with respect to x of the product of g's of x times h of x. Later on, when we take some examples, this will be very useful. So the equation, the formula here, if you have a product, take the derivative of the first or any first function, you multiply it with the second function. Then after that, you add it with the derivative of the second function, then multiply it with the first function. So alternate. It's the alternate. This is called the product rule. Some books uses instead of g's of x and h of x, they use u and b, so derivative of u times b, where u and v are functions of x, and this will be u dv plus v du. It's the same. It's just in the other arrangement. U here and v are functions, g's of x and h of x with respect to x. So you take the first function, you multiply it with the derivative of the second, then you add it with the product of the second function and the derivative of the first. So alternate. So it's the same thing. It's the same thing. So we can also rearrange our derived formula. This is the same, h of x times the g derivative of g's of x with respect to x, then plus g's of x times the derivative of h of x with respect to x. So it's just the same with different notations. Now that's the product rule. So the last one will be, of course, the opposite of product. We have the derivative of the quotient of two functions. And we call this one the quotient rule. So we can derive it again using our method from the previous number 2. So here we let again f of x to be equal to the quotient of two functions g of x over h of x. And before we continue, we again first need to determine what is f of x plus delta x. So this will be g of x plus delta x all over h of x plus delta x. And we can now take the limit. So the derivative of g of x over h of x will be equal to the limit as delta x approaches 0 of f of x plus delta x, which is this one, g of x plus delta x all over h of x plus delta x. Then we subtract f of x, which is g of x all over h of x. Then we divide it with delta x. Then we can now simplify this one. So first, the numerator, we can take the LCD, we can subtract them. So what's the LCD? We just multiply the denominators. That's delta x times h of x. Then at the top, you have g's of x plus delta x times h of x, so cross multiply, times h of x, then minus g's of x times h of x plus delta x, then all over delta x. Then simplifying further, we can put the denominator. This is over 1, so this one times this one, and this one times this one. So algebra, this will be equal to g's of x plus delta x times h of x minus h of x plus delta x times g's of x, then all over delta x times h of x plus delta x. So h of x plus delta x times h of x times delta x. Then we can now again apply some trick on the numerator. Here, so we need to add again 0. Delta x approaches 0. So g's of x plus delta x times h of x. So we need to add this time g's of x times h of x. So we add g's of x times h of x. So we did change the equation, but to neutralize this one, we need to subtract it again, g's of x times h of x. Then we subtract the last part, h of x plus delta x times g's of x. Then all over the denominator, h of x plus delta x times h of x times delta x. Then we group them again. Delta x approaches 0. So we need to group them, or we factor out something, common terms. Here, we can factor out h of x. H of x. So h of x, we multiply it with this part. The remaining will be g's of x plus delta x. Then this one will be plus, or we can take the other one here, minus, because we need to have g's of x plus delta x minus g's of x. Remember, why do we need to do this one? Because we know that the definition of a derivative is delta x delta x minus the function x. Okay, so we need to subtract and factor out h of x. So the term we use this one, just like what we did in the first example. Then for the next again, so this will be, because this is minus, so it should be minus. We can factor out g's of x. Then, so this one, we use this to here. H of x plus delta x, we factor out g's of x. Then the remaining term here, this is plus, and we factor out the minus. So in order to make it a plus, we need to multiply minus with a negative. So this should be minus, because if we distribute it, negative g's of x times negative h of x will be equal to positive g's of x times h of x. Then we continue, times h of x times delta x. Then we can now separate them, but we have here h of x plus delta x and h of x. So it's fine. So this will be the limit of delta x as delta x approaches 0 of g's of x plus delta x minus g's of x. Then I divide it with delta x. Then times, I need still to multiply it with g's of x or h of x. H of x. Then to the second part, so this will be minus h of x plus delta x minus h of x all over delta x. Then I multiply it with g's of x. Then where's the h of x plus delta x times h of x? So I just need to multiply it here. 1 over h of x plus delta x times h of x. Then we cannot take the limit. We can distribute the limit. So this will be equal to, here, the limit of this part, as delta x approaches 0, is equal to the derivative of g, derivative of g's of x with respect to x. Then I multiply it with the limit of h of x. So this part, what's the limit of this one? As delta x approaches 0, it will remain the same. So I just multiply it with h of x. Then to the right side, this one is again the derivative of h of x with respect to x. Then I need to multiply it with the limit of g's of x, which is just g's of x. Then here, at the last part, what's the limit of this one as delta x approaches 0? So this will be equal to 0. So the only remaining will be h of x. You multiply it with h of x, then that will be h of x squared. So the whole thing here, we just multiply it with 1 over h of x squared. So to simplify this one, the derivative now with respect to x of the quotient of two functions, g's of x over h of x is equal to h of x times the derivative of g, then minus g times the derivative of h. All over the square of h. And this will be our quotient rule. Take note of this, it's minus. So you cannot interchange them. Your h here, h of x, is the denominator, the function at the denominator. So it should be the first one, or the first term. So in other books, again, they use as UDV something. So the derivative of u over v is equal to v du minus u dv all over v squared, or there's a mnemonic used before. They say it's law d high. Law times the derivative of the high. Law, the denominator, law, times d high. Law d high minus high d low. Law d high minus high d low over low squared. So you can memorize it as law d high, law d high, law d high. So it means first the denominator, then d high, derivative of the numerator, then minus. So this is quotient rule. So we will be having example later on when we discuss the different derivatives of functions, algebraic functions.